Good day. Welcome to Mrs. Paul's unit review of functions. Now just remember, as we do these reviews, I've been saying in the other videos that I really suggest that you pause the video so that you have an opportunity to try to follow on your own, and then you unpause it when you're ready to come back to me and hear how to solve it. Now, in question 1, we have which ordered pair XY could be included in a set above so that the set would remain a function of X. Now, for those students who I have who are looking for me to sing my function song, I'm not singing it on YouTube. If you want to hear it again, you have to see me during Orange Day, on any Orange Day lunch, or after school. Now, for this, we have to remember what a function is. Now, when we are trying to determine if something is a function, or in this case, we want this ordered pair to remain a function, we are only concerned with the x coordinates. And to be a function, every x coordinate has to be different. Or another way of looking at it is, in order to be a function, don't repeat the x. So let's go ahead and just highlight our x coordinates. 1, 2, -3, and -5. So in order to remain a function, you just have to make sure that you do not repeat any of those x coordinates. Now, the answer cannot be choice B. Oh, I'm sorry. The answer is choice B, simply because we do not have a -1 listed in our original coordinates, so therefore this will remain a function. So the answer, let's just verify, the answer is not choice A because you already have an x coordinate of 1. Answer could not be choice C. Get rid of that. Answer cannot be choice C because you already had an x coordinate of -2. And your answer cannot be -5 because you already had an x coordinate of -5. So therefore our answer for number 1 is B. Now moving on to number 2. Which is the domain of the graph shown below? Now, for this question, and there's another one coming up later that I recall, notice that we have two distinct starting and ending points on this particular graph. So just note, point, point. Now, they want to know the domain, so the only thing I care about is what's happening along that x-axis. So my lowest x-coordinate is right here, which is -7, and my highest x-coordinate is here, which is +7. So my correct answer for that one, number 2, would be choice H. Now, question 3. Which of the following data sets does not represent a function? So this one, I'm actually looking for the coordinate that repeats. Whenever we want a choice that is not a function, you're looking for the one that has a repeating x. Now look at choice A. 2 goes to the 0, 4 goes to the 1, 5 goes to the 1 as well. This choice A is a function. None of our x coordinates repeat. Now look here at choice B. The 1 goes to the 0, that's fine. The 2 goes to the 0, and the 2 also goes to the 4. Our poor 2 is confused. This choice B is not a function because your x coordinate has repeated. So our answer for question 3 is choice B, due to the 2 repeating. And again, this is called a mapping. Now looking at question 4, which is the domain and range of this function? Well, here we have f of x is equal to -3x plus 6, and everyone recognizes this as just a simple line. Y equals mx plus b, so our y-intercept is 6, our slope is -3, and they want to know what our domain and range is. So let's go ahead and get a visual on this one. So let me clear out these that I already had in here. Alright, and let me go back to the top. So now we have -3 And again, just be careful that when you're typing in a negative, make sure you're using this negative key and not the subtraction key. And I want to be back in y equals, so I'm sorry. So negative 3x plus 6. All right, let's go ahead and hit graph just so we can get a visual of what's happening with our domain and range. And honestly, one of the best ways to work with domain and range when you're given a graph is to really look at what the x and the y cannot be. So in this case, it looks like I do not have any restrictions whatsoever on my x. My x can be as small as I want it or as large as I want, and there's no restriction on my y. So for question 4, because I don't have any restrictions, no height restrictions, it's not stopping, it's going to just keep going, spanning the whole coordinate plane here. So it looks like my domain and range should just be all real numbers. So my domain and range will be, my answer for this one will be choice G, which basically is saying my domain is all real numbers, elements of all real numbers, and my range also all real numbers. Now, question 5. This one is asking me specifically for the domain, so I'm only looking here at my x coordinates. Now, this is different than the question 2 that we did, because notice for this, you have arrows at the end, which means that, hey, this is going on and it's going to keep following this same pattern. So again, I'm looking for domain. I'm looking what's happening with my x coordinates. And my x coordinates, it looks like, hey, this is going to keep continuing over here into the negatives, and this is going to keep continuing over here into the positives. So guess what? It looks like my domain is going to be all real numbers. So my answer for this one would be choice B. Now, let's say instead of asking you what the domain was, let's say they asked what is the range. So let's change question 5 and now ask what is the range. Okay, I'm going to give you a second for that. Okay, so now for the range, you're looking for your high and your low. So on this graph, it looks like my lowest point, if it continues this pattern, is going to be negative 3, and my highest, it would be positive 3. So if this question had asked for the range, then my range would have been between negative 3 and positive 3. Now moving on to question 6, which is on the next page. Now this one is asking us which is the zero of this function. Now there's 2 ways to approach this. One way is, you know what value can I plug in for x such that I get 0 as an answer? So let's approach it that way first, and then we'll do it graphically. So what number can I plug in for x so that I get 0 as an answer? And we could go ahead and solve this algebraically, or we could just look at it and just talk about it. Now basically, they're saying half of some number minus 8, I need to get 0. So basically, what is the only number that you can subtract 8 from and get 0? Well, great. So this half x has to be 8. So then you ask yourself, half of what number would give you 8, which is 16? So our answer is choice J. But if you were really into, let's solve this algebraically, we're going to go ahead and solve it algebraically. Go ahead and bring down your equal sign, and then we're going to add 8 to both sides. All right. And then now we have to deal with this fraction. And actually at this point, half of what number gives you 8? The answer is 16. But again, if you just want to do it algebraically, in order to get rid of our fraction, remember we multiply every term by our LCD, because the LCD is the great fraction buster. So we're going to multiply both sides by 2, or each term by 2. 2's cancel, and you're left with 2 times 8 is 16. Okay? Now, let's say You're like, you know what, I want to do it graphically. Let's put it into the calculator. So another way you can do a zero question is go ahead and type our function in. So 1/2 x, if, depending on which calculator you have, you may be able to type in your 1/2 by doing alpha y equals and typing in your 1/2 like this, and then arrow out. Or, if you do not have the calculator that does this, which is typically the yellows, just type in your fraction like normal. So just 1/2, 1 divided by 2, x, minus 8. So when they are asking us for the zero, they're also really just asking us, you know, what is the x-intercept? Where does this graph cross the x-axis? Now, looking at this, I can't see where it crosses the x-axis. But one thing we do know is that it's sure enough crossing the x-axis somewhere over here past 10. So the only reasonable choice that you have left here is 16. Something else you can do is you can also look at the table. And I'm going to go ahead and set my table back to its default setting. Now let's go ahead and look at our table. And we're looking to see which x value gives us a y of 0. And it was right here. Alright. So this is another option here. Alright. So another way you could do a zero question is go to your table and see which x coordinate gives us a y coordinate of 0. So this is why x is 16, or you could do it based on a visual. All right, now let's look at question 7. And let's just get rid of pieces of this. Kind of went over into my other problem. And I'm just going to push this one up. All right, now given the function below, this is question number 7. Given the function below, which is f of -6. Now, our x coordinate is -6. Okay. That's our x coordinate of -6. And they want to know what is the y coordinate. So let's just find it here. My x coordinate, when it is -6, my y coordinate is -2. So our answer is choice B. And we're moving along nicely here. All right. Now, this is question 8. Now, question 8, the graph didn't show up. I'll bring it up on the calculator. The graph of this function, f of x is equal to -3x plus 3 is shown. What is the value of f of -1? Now, we can actually do this without using the graph. So let's do that first. So f of -1 just simply means take this -1 and substitute it in for each of your x. So f of -1 is equal to -3 times -1 plus 3. -3 times -1 is +3. And 3 plus 3 is 6. So our final answer is choice F. Now, using the graph, we're going to have to put this in ourselves. -3x plus 3. All right. Now, when x is -1, I have to find out what its corresponding y value is. And honestly, from this graph, it's really hard to tell. So let me go to the table. If I push a second table, a second graph, and I'm looking for x is -1. Now, let's say I didn't want to scroll all the way up here to get to -1. You could go ahead and hit second window or second table set. And I want this table to start at -1 because I really don't want to scroll all the way up. Now when I go back to the table, it's where I want it to be. So f of -1 is 6. So you could do this question that way as well. You have options. You get to choose whichever option works best for you. Now looking at question 9. The numbers in this table follow a linear pattern. Now, honestly, for this particular question, you could just use basic, just looking for a sequence, looking for a pattern. Your P is decreasing by 1, but notice what's happening with this W. It looks like it's decreasing by, 3. So the difference between the 14 and the 11 is 3. It looks like the difference between the 5 and the 2 is 3. The difference between the 2 and the -1 is 3. It looks like it keeps subtracting 3. So therefore, all we need to do is do 11 minus 3, and we get that our answer here is 8. And then of course, if you go ahead and put the 8 in here, 8 minus 5 is 3. So we could have just looked for the pattern for that one. We're not going to make that one harder than it is. So now let's move on to number 10. All right, what are the values of this function, f of x is equal to -5x plus 7, when our domain is -2, -1, 0, and 1? A number of different ways we can solve this one. If you wanted to do this one by hand, all we need to do is take each of these x coordinates and plug it in. So let's do f of -2 first. So that's going to be -5 times -2 plus 7. -5 times -2 is positive 10. And 10 plus 7 is 17. Okay, but answer cannot be F or G because we don't have 17 in those sets. So my answer is either going to be H or J. Now let's go ahead and plug in -1. So f of -1 is equal to -5 times -1 plus 7. -5 times -1 is positive 5. And 5 plus 7 is 12. So we need to have 7 in there. Okay. Now let's plug in 0. And when we plug 0 in, we're going to have -5 times 0 plus 7, which is just going to give us 0 plus 7, which is 7. And lastly, let's go ahead and plug in f of 1. Which is -5 times 1 plus 7. So that's -5 plus 7, which is a positive 2. So it looks like our answer here is J. 17, okay, 12, 7, and 2. Our answer is J. Now, another way of doing this is you could have used a calculator. So let's go ahead and try that method as well. Okay. So we're going to go ahead and type in our function, which is -5x plus 7. Now you have a choice here. We could just simply go to the table and look for those x coordinates of -2, -1, 0, and 1. They're all in order. But let's say they weren't in order. What you could do is you could go back to your table set and say, look, instead of automatically giving me every single x value there is, how about you ask me what I want? So I could go ahead and set this to ask, and just make sure you push enter on that. Now when I go to my table, I don't have anything, which is great because I get to put in exactly what I want, which is -2, -1, 0, and 1. So here you can see This is another option here as well. So my answer is my answer, my range here is 17, 12, 7, and 2. Okay? And honestly, doing a problem two different ways on the SOL is not a bad idea, because if you do it two different ways and you get the same answer, you should feel really good that your answer is correct. But if you do it two different ways and you get two different answers, then that's saying, you know what, we may need to flag that question for review and come back to it. Now, question 11. The table below shows the x and y values of a linear function. Which ordered pair represents the x-intercepts? Now, just remember here, x-intercepts, that just simply means where my graph crosses the x-axis. Now, what you can do here, if you're like, well, I'm not too sure, is it the y that's 0, is it the x that's 0? How about you just take these points and just plot them? And when you plot these points, see which one ends up on the x-axis, and that will simply be your x-intercept. So, I mean, obviously here, we could eliminate some choices. It's -2, -6. And we can just make a little makeshift graph here. -2, -6 would be somewhere over here. -1, -4 would be somewhere over here, so that's not a possibility. Now, 0, -2. 0, -2 would be on the y-axis, but they actually x-intercept. 1, 0 would be right here. So this is our answer. Our answer is 1, 0, because 1, 0 is on the x-axis, which makes 1, 0 your x-intercept. So our answer is choice C. And our last question here in our Unit 3 review is, what is the y-intercept of 4x plus 8y is equal to 12? Just getting rid of this. All right. Now, you have two ways of actually doing this particular question. One way is get this equation into slope-intercept form in order to identify the y-intercept, or you can do it algebraically, which is, well, for our y-intercepts, our x-coordinate is 0, so you could plug 0 in for x. So let's do it both ways. If I'm doing it algebraically, I know that for my y-intercept, it's the x-coordinate that is equal to 0. So I'm going to plug 0 in for x. So I will have 4 times 0 plus 8y is equal to 12. 4 times 0 is 0. 0 plus 8y is 8y. And now divide both sides by 8. And we will get that y is 12 over 8. Now chances are, I didn't look at the choices here, but I have a feeling they actually reduced this. So it looks like we could divide this by 4, divide this by 4. So it looks like our y-intercept is 3 over 2. Now let's just see, are the answer choices in fraction form, or are they in decimal form? So what was our answer again? Our answer was 3 over 2. So it looks like our answer is choice G. All right. Now, another way you could have done the same problem was you could have gotten y by itself and then just identified the y-intercept from the slope-intercept form of the line. So we have another way we could do this. So let's take a look at that. So we have 4x plus 8y is equal to 12. Let's go ahead and get y by itself in order to get it into slope-intercept form. So again, you can subtract 4x on both sides, but usually I just like to just move it over. So therefore, if I do not want that 4x on my left, I need to bring it over to the right. So it's just going to go to its opposite side and just become -4x since it changed sides of the equation. So I took the square, brought it over, and when I brought it over, it went to its opposite sign. Now, y is still not by itself, so now we're going to divide each and every term by 8. Our 8's cancel. We're left with y is equal to negative 4 over 8x plus 12 over 8. Now we have our equation in slope-intercept form, and we can identify our y-intercept. Y is x plus b. Our y-intercept is 12 over 8, which is the same thing we got over here, which of course we will reduce to 3 over 2. And that concludes our review of Unit 3 functions. Have a great day.